This is ece23 performance task number 8. So for this performance task, we will discuss about the binary machine. So for the objective, we are able to demonstrate the principle of information theory by determining the entropy and sending message by using Shannon's and Hartley's equations. I have here my reference for building the binary machine. So we will determine the following. We will design two different binary machines that will be used to compute for the entropy and the necessary analysis and calculations, and we'll find the probability of occurrence of each letter based on our binary machine, and we'll compute for the entropy using probability method, Hartley equation, or Hartley function, and we'll make a summary by comparing the results and draw our conclusion on which machine is better. So I will be designing first the binary machine based on our reference before. So we have here our first binary machine. So with my reference letters, so ACEHINOPY. If you are asked by a question, is it ACEH, then if yes, it will represent as 1, and if no, it will be represent as 0. If it's A, so it will be represent again as 1, and it will be continue for the rest. Solving for our probabilities, so each level will be divided by 2. So for the second level, that's 0.5, but our A is on the third level, so our probability, so 0.5 divided by 2, that would be 0.25, and the same for the letter I, that would be 0.25, and the rest will be the rest of the levels will be divided into 2 to get its probability. So for this part, 0.25, 0.25, and I'll do the rest for each level. And I will do for the bit pattern. So we will base this now, and we will fill up this part now. So for our A, symbol A, that's 0.25. Our C is 0.125. Our E is 0.625. And our H is also 0.0625. And our I, that's 0.25 because that's on the third level. So for the number bit, we will follow the pattern. For the letter A, the pattern are 1 1, so that would be 1 1. And for the C pattern, the pattern for C would be C1 0 1, so that would be 0 1 0 1. And the rest I will do just do it. We will now solve for the entropy using the probability method. Each probability will be multiplied to the number of occurrence and the number of bits. So for PA, we have, so for 0.25, there are 2 occurrence. So 2 times 0.25 times the bit number, and that is 2 bit, so that will be multiplied into 2, and we will add all the probabilities together. So our H would be now 2.815 bits. Next, we will use the Hartley equation. So H is equals to negative summation I, probability I times the log of 2 times the probability I. So using the probabilities, the list of probabilities, we are able to come up with this equation. So H is equals to negative the probability 0.25, so that's it occurred 2 times, so 2 times 0.25 log 2 of 0.25, and will be added through the list of probabilities. So the total would be 2.815 bits. So we will proceed to the binary machine 2. So the same method that we do from the binary machine 1. So for summary, we have our two machines here. So for binary machine number 1, it has a 2.85 bits of entropy, and for solving for its efficiency, we'll just divide the entropy to the H max. So we come up with this value, and so for RE it is 0.112, because that's 1 minus the efficiency. So for the binary machine 2, the entropy is 1.997 bits. So the efficiency for the binary machine 2 is 0.630, which is lower than the binary machine 1, which is better. So the redundancy is 0.37, and the redundancy must be high as possible to maximize the transmission. So the binary machine 2 has the lowest entropy, the higher probability, the most predictable, and the least random, and which is the opposite of the binary machine 1. For binary machine 1, more information is needed to be transmitted to get a desired outcome. And for the binary machine 2, the less information is needed to be transmitted to get the desired outcome. So for summary, binary machine 2 is much better than binary machine 1. So that's the end for ece23 performance task number 8. Thank you.